Hi everyone, my name is Chardon Maldonado, Technical Director of the Caribbean Coastal Ocean Observing System, better known as CARICUS. We are one of the 11 ocean observing systems under the IUS enterprise, and our geographical extent encompasses Puerto Rico and the U.S. Virgin Islands. I was invited today to expand on what can OASIS do to promote a safe ocean. As you are aware, Caribbean Pacific and Indian Ocean small island developing states are extremely vulnerable to hydrometeorological hazards. These islands are frequently struck by cyclone, thunderstorm, coastal storm surges, river, coastal and flash flooding, drought, strong wind, among others. This hazard can severely impact these islands by taking life, destroying infrastructure and livelihoods, and causing coastal erosion, among other impacts. These are just some examples of the impacts of these extreme events in Puerto Rico. We must remember that climate change is likely to increase the frequency and severity of such hazards, given the small size of the islands and the challenges ahead. Further progress in coping with the weather and climate-related extremes will depend on making greater investment in observing networks, accurate forecasts, communication systems, and data service delivery. As an example, CARICUS built an observing system having in mind that knowing about ocean weather in advance can help minimize disruptions to the everyday public and commercial activity, keep coastal and maritime workers safe, and aid marine conservation efforts. Dataset from these observing systems has helped facilitate investigation into the drivers of extreme events and improve capability to forecast these conditions on different time and spatial scales. Improvement in our ability to forecast weather conditions weeks in advance help communities prepare for an event or for an extreme event. One of the forecast pros that we want to improve to help our communities is the tropical cyclone intensity forecast. For this, CARICUS has been deploying underwater gliders for almost 10 years during the Atlantic hurricane season. The value of per-collocated ocean atmosphere observation to improve model prediction has been of great value. Data from the gliders have shown that upper ocean conditions play an important role in the tropical cyclone intensification. And the data also allow us to represent the ocean component in ocean atmosphere coupled intensity forecast models, and this model has been improving and are starting to reduce official intensity error, in part due to the improved atmospheric and ocean data simulation techniques. However, we need to translate this into operational product, and for this we need to gather more information and maybe deploy more instrumentations in the Caribbean to also learn from other phases of these tropical cyclone events. As I mentioned before, we have other hazards that can severely impact the island, and to provide information about them, we depend on global and or regional scale models. However, these forecasting models are not sufficient to resolve all the near field dynamics or the ocean coastal dynamics which occur around small islands. So forecasting island scale phenomena is not possible without a fully coupled atmospheric oceanic system. Thus, apart from promoting an effort to improve the forecasting system, we should also start consider other geophysical process or dynamic process that often form around or near the island. Just an example, in our region is important to consider the intrusion of continental river plumes, some mesocale feature with water mass properties, the ocean barrier layers that has been linked to potential tropical cyclone intensification, and some wind conditions. A future forecasting system will need to better resolve this island-induced phenomenon to provide initial and boundary conditions to high-resolution models that will help us develop or improve our nearshore coastal data products to provide information about other hazards such as coastal and flash flooding, coastal storm surges, um, among others. So after learning about some of the challenges and complexity of weather forecasting in the U.S. Caribbean region and small island, what can OASIS do to promote a safe ocean? OASIS can gather information, synthesize a message to assist with the evolution of the ocean observing system forecasting tools. Future changes need to be scientifically motivated and linked to wider benefits to society. OASIS can also share, could also share information about um, new models, forecasting tools, new assimilation scheme, downscaling techniques, parameterization of air and sea processes, information about affordable technology to help those undersampled regions, leverage multidisciplinary activities, um, and find a way to translate all this information into a language that everybody could learn. I know this is a challenge, but it's something that after all the effort to improve and ensure that products are accessible, we need also to find a way to express the message to everyone. I would like to thank you for your time and attention today.